For number 10, I already have 1 in front of the x in the first equation, so I want to eliminate the x in my second equation. So if I take equation 2 and then add a -1 times equation 1 and make this my new equation 2, then this should accomplish that. So x plus 2y minus 3z is equal to -3. Negative x minus y plus z is equal to 0. And then if I add these up, this is going to be 1y, or just y, minus 2z is equal to -3. So I want to update my system. Again, every other equation is going to stay the same. The only equation that I'm changing is the second one. Okay, so then my next step is I want to get rid of the 2x in the third equation. So I want to take the equation 3 and then add a -2 times equation 1, and that'll be my new equation 3. So that's 2x plus 3y minus 4z is equal to -3, and -2x minus 2y plus 2z is equal to 0. So if I add these up, then I'm going to get, 3y minus 2y is going to be 1y, or just y. And then this is going to be a minus a minus 2z, and that's equal to -3. So if I update my system, then I have x plus y minus z is equal to 0, and I have y minus 2z is equal to -3, and y minus 2z is equal to -3. So you can kind of see here that we have a situation where our equations are the same. So let me actually go to the next slide, and I want to do equation, equation 3. Let's do plus a -1 times equation 2 to be the new equation 3. So I have y minus 2z is equal to -3, and -y plus 2z is equal to a positive 3. So if I add these up, I am going to get 0 is equal to 0 because they were the same equation. So I want to update my system. This will be x plus y minus z is equal to 0. Y minus 2z is equal to -3. And then 0 is equal to 0. So this is a true statement, which means it is going to be infinitely many solutions. However, when it is infinitely many solutions, we do need to express it as an ordered pair, or in the previous section it was an ordered pair. This will be an ordered triplet. So my first step is I'm going to let z be anything. So z can be anything. And then I want to write the other two in terms of z. So now express x and y in terms of z. Mathematically, this is going to be still very similar to when we were back substituting. We're still going to kind of work our way back up the system. So if you work your way back up to the middle equation, we have y minus 2z is equal to negative 3. And it's not very hard to get y by itself and in terms of z here, because I just need to add 2z to both sides. So y is equal to 2z minus 3. And that'll be another part of my answer. And then lastly, I want to plug both of these into the very top equation. So I have x plus, instead of y, it's 2z minus 3 minus z is equal to 0. So this will be x plus 2z minus 3 minus z is equal to 0. If I combine like terms, I have x plus z minus 3 is equal to 0. And if I move those to the other side, then x is equal to negative z plus 3. So this would be the third part of my answer. So I want to combine all of those into my final answer. So that'll be negative z plus 3 for my x, 2z minus 3 for my y, and z for my z. So WebAssign, some of the questions will accept this, or they'll ask for this. Other ones will want it to be in terms of t, so that'll be negative t plus 3, 2t minus 3, and t. So it just depends on how they phrase the question in WebAssign, whether or not you can use z, or if they want you to use t. But the answers are essentially the same.